Welcome students to the first lesson of Algebra 3 or Saxon Advanced Mathematics, same class. We are using the Saxon Advanced Mathematics and Incremental Development 2nd edition textbook. You are welcome to buy that textbook if you want. It is not necessary if you use your spiral notebooks and take excellent notes. So for our first lesson, it's a geometry review. So I created a Quizlet that has all of the terms that are in that geometry review, and we'll go through them, but then I'm going to provide that link to you in the module or the pod that we have so that you can add it to your own Quizlet account, and then you can study it, at your leisure. I do recommend going through it at least once or twice just to make sure that you are up on all of the terms. There might be a few things for those of you that haven't had a full-scale geometry class, a few of the postulates that we maybe didn't memorize in Algebra 2. So let's go through them and see what we have. So we know that a location on a plane that has no dimension is a point. A collection of points along a path is called a curve. A straight curve, which is a collection of points that do not change in height or depth, that is a line. A part of a line with two endpoints is a line segment. Points that lie on the same line are collinear. A part of a line with one endpoint that continues without an end in the other direction is a ray. Two rays that have the same endpoint and go in opposite directions are opposite rays. It's also a straight angle or a straight line. The point where two lines cross is the point of intersection, and a flat surface that has no thickness and extends forever is a plane. And you can see that a plane is just a slice of reality. Here you have the transverse plane, the median plane, and the frontal plane here. Lines that do not intersect and are not coplanar are called skew lines. Any points or lines that are on the same plane are coplanar. A figure formed by two rays with the common endpoint is an angle. An angle that measures 180 degrees, which is a straight line or opposite rays, it was called a straight angle. An angle that measures 90 degrees is a right angle. An angle that measures less than 90 degrees is an acute angle, and greater than 90 degrees but less than 180 is an obtuse angle. Two angles whose sum is 90 are a pair of complementary angles. Two angles whose sum is 180 are supplementary angles. A pair of opposite angles, they're congruent and they're formed by intersecting lines, are called vertical angles. If P is the interior of RST, then the measure of RSP plus the measure of PST is equal to the measure of RST. So all that's saying is that if you have a ray between two other rays to make two angles, then this angle plus this angle equals the exterior ray's measure. It makes 1 degree of measure for that angle. And that is called the angle addition postulate. And it is the same thing for a line. If you have AB and BC, you can add them together and find the length of AC, and that is the segment addition postulate. If they have the same size and shape, then they are congruent. A ray that divides an angle into two congruent angles is the angle bisector. A segment, ray, line, or plane that intersects a segment at its midpoint is a segment bisector. A point that divides a segment into two congruent segments is the midpoint. And these are used to show congruent segments or congruent shapes, and those are tick marks. You can see how we use them here. The number of tick marks indicates congruency to which item. So you're looking for the same number. The same number of tick marks indicates that they are congruent to each other. So if this one had 2 tick marks here, then only these two would be congruent to one another. A point is between two other points on the same line if its coordinate is between their coordinates. And all that means is that in order for a point to have betweenness or to be called between, it has to lie on the same line between those 2 points. If B were just a little below here or somewhere else not on the line, it would not be considered between. It would not have betweenness of points. So it has to be on the line between 2 points, that the line that the points make. All right, a type of logic in which generalizations are based on a large number of specific observations. So you have proof, right? That is inductive reasoning. Deductive reasoning is where you draw a conclusion based on previous proof or something that has happened before. For instance, the sun rises every morning, therefore the sun will rise on Tuesday. That is deductive reasoning. Lines in the same plane that never intersect and are also exactly the same distance apart every place that you would measure them are parallel lines. Lines that intersect to form right angles are perpendicular lines. A line that intersects 2 or more coplanar lines at different points is called a transversal. Angles formed by a transversal cutting through 2 or more parallel lines are called corresponding angles, and we know that if those lines that the transversal cuts through are parallel, then those corresponding angles are going to be congruent as well. 2 interior angles on the same side of the transversal are the same side interior angles, just like the definition says. And the 2 exterior angles on the same side are the same side exterior. Angles between 2 lines and on opposite sides of a transversal are alternate interior angles. We know that if those lines that the transversal cuts are parallel, then the alternate interior angles are going to be congruent. Angles that lie outside a pair of lines on opposite sides of a transversal are the alternate exterior angles. And if those lines are parallel, then we know that they are congruent as well. And here is our parallel lines, properties of parallel lines. If these are parallel lines here, and they're cut by a transversal, then the alternate interior angles are congruent, the alternate exterior angles are congruent, the corresponding angles are congruent, and if a transversal is perpendicular to one of the parallel lines, then it's perpendicular to the other parallel line. And these are the conditions for lines to be parallel. You could check these properties to prove 2 lines are parallel if you have to write a proof for that. So it's something good to put in your notebook to use later on when you need to make a proof about parallel lines. So if 2 lines are cut by a transversal so that a pair of corresponding angles is congruent, the line's parallel. If the pair of alternate angles are congruent, then the lines are parallel. And if the alternate exterior angles are congruent, then the lines are also parallel. The formula for the area of a rectangle is length times width. The formula for the area of a triangle is half the base times the height. The formula for the area of a circle is pi r squared. Remember that because we're going to use it later. 2 points on a circle and all the points on the circle between them is an arc. See, this is an arc right here, but this is also an arc here. It just has to be points between 2 points on the circumference of the circle. The minor arc is the smaller of the 2 arcs. And the major arc is the larger of the 2 arcs. Now the region bounded by 2 radii are called the sector. So this is a sector, but this is also a sector. The interior angle, we're going to do that next, that is the central angle. So it's central angle because it goes to the center point of the circle. When a triangle has all congruent sides and angles, it is a regular triangle, but but it is also an equilateral triangle and an equiangular triangle. Because of the construction of a triangle, if it's a regular polygon, which means that all the sides are the same and all the angles are the same, then it has to be an equilateral and equiangular, because that is the nature of a triangle. And that is why Pythagoras was so obsessed with them, because of their simplicity and because of the rules that we have to follow when we draw them. They always follow the same sets of truth. The sum of the measures of the interior angles of a triangle is 180 degrees. And that is the triangle sum theorem. A triangle that contains only angles that are less than 90 degrees is called an acute triangle, and a regular triangle, equiangular or equilateral, whatever you want to call it, is an acute triangle. A triangle that has one angle greater than 90 degrees is an obtuse triangle, and a triangle with one right angle is a right triangle. Now we know that only a right triangle has a hypotenuse, and the hypotenuse is the leg that is directly opposite the 90-degree angle. A triangle that has no congruent sides is called a scalene triangle, and a triangle with two congruent sides will also have two congruent angles, and that is an isosceles triangle, and it is also called isogonic. That's a word we haven't used before. The perpendicular segment from a vertex to the opposite side, or the side that contains the opposite side, is the altitude of a triangle, also called the height of a triangle, and that's what we use to calculate area when we multiply it times the base. A length that is perpendicular to a segment at its midpoint. So you have a base or a leg, a side, and from the midpoint of that side to the vertex of the angle opposite it, that is called the perpendicular bisector of a triangle. And you can have 3 per triangle because you have 3 sides and 3 angles opposite those sides. We can only accept congruencies in a geometric figure if marked. This is very important when we are doing proofs in geometry or proofs in advanced mathematics. That is our mathematical assumption. We cannot make any assumption other than if a line appears straight, then it is straight. We cannot assume that something is a 90-degree angle unless it has the 90-degree angle, the little square in the corner that tells us it is a 90-degree angle. We cannot assume that lines are congruent or that something is a midpoint unless we are told that things are congruent and that something is a midpoint or a bisector. So we have to look for that information in what we are given before we write the proof. So do not make a mathematical assumptions that you are not told. All right, this is the transitive property, and the transitive property just says that if A equals B and B equals C, then A must equal C too. Simply because, I mean, that's common sense. I mean, that's just common logic. It's not even a big stretch at all to get there, right? This is the substitution property, and it says that if A equals B, then anywhere that you have A, you can substitute B, and anywhere that you have B, you can substitute A. I mean, that's just common sense also. If 2 sides and the included angle of one triangle are congruent to 2 sides. So if you have a side and an angle and a side that are congruent to the side, the angle, and the side of another triangle, then both of those triangles are congruent, because based on the construction properties of a triangle, they have to be. This other side has to be the same length as this one, and these angles have to be the same angle, because when you have 2 sides the same length with the same angle in between, you cannot draw a side that is longer than the other. It just doesn't work that way. That's not how the relationship between the sides of a triangle are combined. And that is called the SAS postulate, or the side angle side postulate. If 2 angles and a non-included side are congruent to 2 angles and a non-included side of another, then the 2 triangles are congruent. And that is angle angle side postulate. And it is only called angle angle side postulate because of the order here. If you have 2 angles and a side that are the same, basically, if you have 3 things that are congruent within a triangle, whether they're angles or sides, then both of the triangles are congruent. That's just a fact. 3 things get you there, right? So, again, that is the angle side postulate, and it's only called the angle side postulate because you have the angle and then an angle and then a side. If you remember on the previous one, we had a side, an angle, and a side. Now on this one, we have an angle, and a side. And then on the next one, we'll have side, side, side. That's side, side, side postulate. So if you have 3 things that are the same in a triangle, then the triangles are congruent, period. Now this is called the hypotenuse leg postulate, and it says that if a hypotenuse and leg of one triangle are congruent to the corresponding hypotenuse and leg of the second right triangle, then they're congruent. Why? That's only 2 things. It's a hypotenuse and a leg. No, it's 3 things. Because if you have a right triangle, we already know that one of the angles are congruent. They're both right. So it's 1, 2, 3 things congruent. 1, 2, 3 things congruent because they share the hypotenuse. It's congruent to both of them. So they have to be congruent triangles. Right? Remember, 3 things. Any 3 things, if they are congruent to one another between 2 triangles, then the 2 triangles are exactly the same. They're congruent. Again, this is angle side angle because of where it's located. Angle side angle. So it's just listing it in the order that it occurs on that triangle. And that's it. That's all of the flashcards. Congratulations. I'm going to put the link in your pod so that you can, or in your assignment, so that you can open it and save it to your own Quizlet account. If you don't have a Quizlet account, then I would highly recommend that you either bookmark this on your device so that you can go back to it and study it, or that you create your own Quizlet account and add it to your set of cards that you have so that you can go back and study it for your lessons and for your tests and for just your own advancement in mathematics. All right, so now that we have done that, let's go to our scratch pad here, and let's do a problem. So we're only going to do one example problem. Yay! Because here is a cool thing that sort of happened. In the ACT, there was something that used to be called quantitative comparison. And in quantitative comparison, you're given a set of conditions that you have to quantitatively compare. And it was very simple in regards to the answers. The answers were always the same. And the answers were A, if A was greater than B. B, if B was less, if A was less than B. C, if A was equal to B. And D, if you didn't have enough information and you could not tell what A's relationship to B was. So those were always the answers. And the ACT used to include quantitative comparison all the time, but they've gotten to a point, for some reason, they've dropped it. They don't do quantitative comparison. And that is the only reason the advanced mathematics books, or Saxon Advanced Mathematics, included quantitative comparison. And quantitative comparison would be something like, if you had a structure or a figure like this where you have 2 intersecting lines and you had K, L, M, and N, right? And you were told that A was K plus L plus M and B was 180 minus N. And you were asked, the quantitative comparison was to compare the 2 and to see what the relationship was. So we can visually determine just by looking at this, we know that M and N, right, are a straight line. So M plus N would equal 180. But we also know that K plus L plus M plus N would equal 360. So we know that N is the smaller of K, L, and M. So our answer would be 180 minus N is still less than, because that would be M plus N. 180 minus N would be the value of M, right? That would be M. And if you have M and then you're adding L and K to it, as in A, then A is greater. So the answer would be A, right? Easy peasy. Those were the things that used to be on the ACT in quantitative comparison. But for whatever reason, the ACT stopped asking those types of questions. Hallelujah. Because you have to wrap your brain around it, right? And figure out a way to compare the two. We have those problems in our book. We actually have 4 quantitative comparison example problems in lesson 1. We are not, this was actually one of them. We're not going to do them because we don't have to. We don't need to know them. Most of this is just logic, right? And if you can go create a proof and use logic to create that proof, then doing the quantitative comparison is kind of redundant. And maybe that's why the ACT doesn't do it anymore. Maybe I'm thinking that they were looking at the quantitative comparison as a way to make proofs multiple choice. They no longer do proofs of pretty much any kind on the ACT. And this was the closest that they had to them in the first place. So, because they don't do them, we don't have to do them. But we are still going to do proofs because that is logic is a large part of mathematics. It's a large part of geometry. And understanding why is the whole point of algebra. How we get there, what it means, why we did what we did, those things are important. So we are going to do the proofs. We might not do all of the proofs, but we no longer have to do the quantitative comparison. So we will disregard that part and those problems within our curriculum this year and going forward. So that being said, let us clear the page, and we are going to do the only example problem that is not a quantitative comparison in lesson 1, and that is 1.1, and we're going to find the area of a sector of a circle. All right, so I have, let me see, this is about the center, and I have a sector here that is 126 degrees, give or take. It looks pretty close. And what we need to do is find, I didn't mean to do that, I meant to do this. We need to find the area of this sector right here. Of the circle, and I'm just going to draw it in or shade in the part that we need to find. That's good enough. All right, so we're going to find the shaded sector. Sorry, my handwriting is very atrocious. Find the area of the shaded sector. And the radius equals 2 pi, or 2 times square root of 5 meters. That is the radius. All right, so how do we find the area of a sector? Well, first we find the area of the circle, then we determine the percentage of the circle that the sector is, I guess. We find what that percentage of the sector is represented, or what percentage of the circle the sector represents. That's a better way of saying it. And then we multiply the two. We multiply the percent times the total area of the circle, and then that is how we find the area of a sector. So We are not given the degree of measure here, but we know how to find it. We know that a circle is 360 degrees, and if we subtract this degree of measure, then we come up with 234, right? 234 degrees of the green section here. So I'm going to write that just so we have it, 234 degrees right here. Okay. So now we know we could find the percent. And the way we find the percent is we just divide. 234 divided by 360. That is how we find the percent. And once we find that percent, we are going to multiply it times the total area of the circle, which is pi r squared. So pi times, actually I think I'm going to use a bracket here, sorry, because I need to use more than one parenthesis. So pi times r squared, which is going to be 2 times the square root of 5 meters times 2 times the square root of 5 meters, all in a bracket. All right, so now we can go ahead and do what's inside the parenthesis first. And we know that the square root of 5 times the square root of 5, that's going to be 5. And we know that 2 times 2 is 4. And we know that meters once times meters twice is meters squared. And we know that we are multiplying it all by pi. So we have two, hang on, I'll just go ahead and do that first. 234 divided by 360 is going to be 0.65. And this is going to be 20 pi meters square. So 65% of 20 pi meters squared. 65% or 0.65 times 20 gives me 13. So 13 pi meters square is the area of the shaded sector. And conversely, the area of the unshaded part is going to be 7 pi meters squared because the whole thing is 20. So this is 13, this has to be 7 because 13 and 7 make 20. All right, and that is how you would find the area of a sector. It's not complicated, you just have to think it through. Find the percent of the side that you want or the sector that you want. All right, find the percentage, and that is just whatever that degree is over 360. Do the division on your calculator, you get 0.65. And then you calculate the total area and multiply that percent times the total area, and that gives you the area that you're looking for that sector. Easy peasy. And that is all we have for lesson 1. Please go back and review your Quizlets. If you want to write them down in your notebook, that's probably a good idea. You will not have to then go back and keep finding the Quizlet when you want to study. You'll already have it in your notebook. So I highly recommend doing that as a point of reference. Or, since we did the Quizlet in the video, you could just take notes while you're watching the video. There's another idea. All right, so I will see all of you in lesson 2.